Hello everyone. Today I'm going to discuss with you our next topic, that is chemical kinetics. Okay. Now, what is chemical kinetics? First, I'm going to start with the definition of chemical kinetics. Chemical kinetics is something that tells us about the rate of reaction. Okay. That with which speed it is going to change, means with which speed a reaction is going to get completed. So that is chemical kinetics. It is a study of the rate of a chemical reaction. Now what is it? Is a study for the rate of chemical reaction. Okay. Now what is rate of chemical reaction? Rate of chemical reaction can be defined by change in concentration of reactant or product in unit time. Means if we are going to say that this is the rate of chemical reaction, then we need to note that the change in concentration of reactant upon time taken can be the rate of chemical reaction. Or we can say that change in concentration of product upon time taken is also defined as rate of a chemical reaction. Okay. Now, I just want to tell you that in the change in concentration of reactant, as you all know, that reactant concentration is going to decrease. Reactant concentration is going to decrease. Product concentration is going to increase. Now, change in concentration of reactant. So, we need to put negative sign in front of the reactant concentration. For example, reactant concentration is changing from R1 to R2. So you need to put the final concentration here, R2, minus the initial concentration, R1. And R1 must be equal to must be greater than R2, because R1 is reactant concentration at time T1 is greater than reactant concentration at time T2. Okay, this is at time T1, reactant concentration at time T1, and this is reactant concentration at time T2. So also the time taken means T2 minus T1. So this is the reactant. But you know that concentration cannot be negative. Concentration cannot be negative. So we put a modulus over here, or you can put a square bracket and negative sign in front of R2 minus R1, so that you will get a positive value of concentration of a reactant. Now change in concentration of product. How we can say that? Change in concentration of product. P2 minus P1. It's always final concentration minus initial concentration. So final concentration of product minus initial concentration of product. Or you can say concentration of product at time T2 minus concentration of product at time T1. So T2 minus T1. Okay. So P2 is always greater than P1, because P1 will be the product concentration at time T1, and P2 is the product concentration at time T2. So this is the change in concentration for the product, this one and for this one. Okay. Now, so I can say that this is just an average rate of reaction. What it is? Average rate of reaction, where you need to think about the average. By taking average, you are going to get the results. Okay. Now this is our average rate, and now after that the instantaneous rate. What is an instantaneous rate? Instantaneous rate means at a particular time. Means at a particular time, you can say the rate of a reaction is equal to minus dr by dt, instantaneous time, it's a small time, or plus dp by dt, plus dp by dt. This is the instantaneous rate that is mostly used in the chemical kinetics, okay, in the chemical kinetics reaction, rate of reaction, okay. Now you can see that I have covered rate of chemical reaction, okay. After that I have covered uh, average rate, instantaneous rate. Here it is written incorrect, the, but the correct one is minus R2 by R1 divided by T2 by T1. Now this is also called the slope of a tangent. Okay, slope of a tangent, because slope is equal to y2 minus y1 upon x2 minus x1. Okay, here also y2 minus y1 upon x2 minus x1. Okay, now the next one is instantaneous rate. See, it's an instantaneous rate. Instantaneous rate means at a particular time. So if I want to explain you, suppose I have this reaction AA, BB, CC, DD, and I want to write the rate of reaction for this particular reaction. How I can write in terms of instantaneous rate? You need to put the coefficient in the reciprocal. Okay, like 1 by A minus dA by dt, because this is rate of disappearance of A. Okay, is equal to 1 by B minus dB by dt, because it's also a rate of disappearance of B. Okay, is equal to 1 by C dC by dt. Now it is rate of appearance. I have already told you reactant is also going to decrease. That's why we need to put a negative sign to have a positive value of concentration. So that's why we are putting minus sign over here, but we are not putting minus sign over here. Rate of appearance of C. Okay. After that, what? 1 by D dd by dt, rate of, this is rate of appearance of C, this is rate of appearance of D. I hope I am clear to you. Now this we have covered rate of disappearance, decrease in concentration of R divided by time taken, increase in concentration of P divided by time taken, plus delta P by delta T. Okay. Now after that, if I'm writing rate of disappearance of A, means decrease in concentration of R divided by time taken, we can write it like minus dr by dt. Here we can write increase in concentration of P plus dp by dt. So this is rate of appearance and rate of disappearance. You can write it like this also, minus delta R by delta T. This is the average rate and the most of the change. This is a small change, okay? Or plus delta P divided by delta T. Now, the next one is factors influencing rate of chemical reaction. This is the most important and the questions that is going to be asked in the exam. I will discuss it with you. Suppose first factor is the concentration factor. Okay, first factor is concentration factor. With the increase in concentration of reactant, increase in concentration of reactant, concentration of reactant, rate of reaction will increase. Okay, then after that, temperature. With increase in temperature, the rate of reaction becomes almost double. Rate of reaction becomes almost double. Means reaction is going to get faster in the high temperature range than in the low temperature range. Okay, after that, this is the temperature. With the 10-degree rise in temperature, the reaction rate almost becomes a double. Now the next one is the presence of catalyst. Presence of catalyst. Catalyst is going to enhance the rate of reaction. Catalyst will enhance the rate of reaction by lowering the activation energy. Activation energy. Now, what is an activation energy? I'll explain it to you in the next part. Um, but here I am going to tell you that suppose I have reaction coordinate on the x-axis and potential energy or energy on the y-axis. This is our energy profile diagram. Okay, now here we have reactant energy, here we have product energy. From the reactant energy to this energy, this is called the activation energy. By a catalyst attached to the reactant or the product to lower this activation energy, because this is the minimum barrier that is required to be covered by the reactant to go to the product. Okay, this is the minimum energy barrier that is required, but by adding the catalyst, uh, uh, this activation energy is going to get decreased because the catalyst lowers the activation energy, and that's why the reactant can easily compensate this energy and go to product side. Okay, so this is the lowering of activation energy. Next one is surface area. As the surface area increases, area increases, rate of reaction also going to increase. Also increase. Okay, now this is done. Present increase with the catalyst, greater the surface area, faster the rate of reaction, and lower the activation energy, faster is the reaction. I have covered it with you. Now the next question is, so what they can ask, the question regarding this topic is, they can ask the temperature effect, that with every 10-degree rise in temperature, 10 degrees Celsius rise in temperature, rate of reaction almost become double. Uh, then the second question that may be asked is the catalyst effect. they can ask you that whether the catalyst is going to affect the chemical reaction or not. You will say that the chemical reaction, it will only decrease the activation energy to enhance the rate of a reaction. Okay, then the surface area of the reaction, surface area increases, rate of reaction also increases. So this they can ask you. Next one is rate law. Now what is rate law? Rate law, it's an expression. It's an expression that I am going to show you how to write. Okay, suppose I have AA, BB, CC and DD. Suppose I have this one, CC and DD. I want to write rate law for this reaction. Okay, for this reaction, I can write rate law as K, A to the power some coefficient alpha, B to the power some coefficient beta. Alpha and beta may or may not be equal. Be equal to small a, small b. Okay. See, it's an expression in which the reaction rate is given in terms of molar concentration of reactant with each term raised to power which may or may not be equal, may not be same as the stoichiometric coefficient of reactant in a balanced chemical equation. So this is just an expression in which we are putting molar concentration of reactant side raised and the product there and which raised to the power alpha and beta. Alpha and beta may or may not be equal to A and B, which are the coefficient in the balanced chemical equation. So this is a rate law. So we have covered this. Okay, we can write rate law as minus dr by dt2 because this is the decrease in concentration of reactant with the time. Okay, so next one is R. What is rate constant? So I have written one K over here. K is rate constant. Rate constant. Okay, rate constant is equal to rate law. Rate constant is equal to rate law when concentration of A is 1, concentration of B is 1. Okay, so rate law is equal to K at this time. Okay, now what are the rate constants for the 0, first and second order reaction? Before that, I want to show you again this. I want to show you again the unit of rate of chemical reaction. Unit of rate of chemical reaction can be written as, if it's a concentration, means change in concentration of reactant, then you need to write mole divide by time. Concentration mole per liter and the time is in seconds. So always the rate of chemical, the unit of rate of chemical reaction is mole per liter per second. Okay, chemical reaction is mole per liter per second. Now if the concentration, instead of concentration we use pressure, then you need to choose atmosphere per second because here instead of concentration we have pressure. Pressure unit is atmosphere and time unit is second. Okay, now the unit of rate of reaction. I told you that rate always has unit mole per liter per second. Okay, it doesn't change at all. Now, what is rate constant for the order, for the zero order, for the first order, and for the second order? So, what are the order? We don't know what are orders, so we need to know what is the order of a reaction. So, for an order of a reaction, the reaction, what we need to put? Suppose we have AA, BB, CC plus TD. Rate is equal to K, A to the power alpha, or 1, B to the power 2. So 1 plus 2. The order of reaction is the sum of powers of the concentration. So this is a third order reaction. This is a third order reaction. See, sum of power of concentration of reactant in the rate law is called the order of a reaction. Now, next one is molecularity. The number of molecules that is going to attach to each other, that is the molecularity of a reaction. For example, if we have two molecules A plus B reacting gives C plus D. So this is by molecular reaction. A giving C plus D, this is a unimolecular reaction. Remember that more than three molecule collision at the same time. Collision at the same time is difficult. So molecularity of a reaction cannot be more than 3. Okay. So this is molecularity. Now, what is the difference between the molecularity and the order of a reaction? Order, molecularity. First difference is order is experimental. Molecularity is theoretical. Second one is order can be negative, zero, fractional, integer. Molecularity cannot be zero or negative. Zero, negative, or fractional. It's always the integer value. Okay. Order. Now these 2 points are more than enough for the order and the molecularity difference. Now the next one is the number of reacting species taking part in the elementary reaction colliding to bring out a reaction. So this is the molecularity of a reaction. Now, to explain the rate constant for the order of zero order, first order, and second order, how we can write it? Suppose we have rate law like K A power 0. A power 0 means 1. Anything which has a power 0, its value is 1. Okay. Rate law is rate law unit is mole per liter per second. So K is mole per liter per second. Now the next is K, small k, Ka power 1. Mole per liter per second, K mole per liter. So mole per liter cancel. K is second inverse. So this is the unit of first order. Now the rate law, Ka power 2. K mole per liter का whole square, mole per liter per second, K mole square per liter square, mole per liter per second. So now I can write it here, mole per liter per second, mole square per liter square, K. Okay, mole cancel, per liter 1 liter cancel, mole inverse liter per second is K. Okay, so we can write it as molarity M inverse second inverse. Okay, so we can write it mole inverse liter per second. Now one simple method to calculate the unit of the rate constant is K is equal to mole 1 minus n second inverse, means 1 minus 1 0, 1 minus 0 mole inverse, molarity means concentration inverse. Okay, molarity m, m 1 power m power 1 minus n second inverse. See, if it's m power 1 minus n, then mole per liter power 1 minus n second inverse. So mole per liter per second for the zero order. For the first order, 1 minus 1 0, anything which has power 0 will be equal to 1. So then second inverse, then it's 1 minus 2 mole, molarity minus 1, then mole inverse liter per second. Okay, so this is all for the rate constant values. Now the next ones are order. I have explained to you, and the molecularity is also done. Okay, let me complete this pseudo first order reaction. Now what is pseudo first order reaction? Suppose I have C2H5 COO C2H5 plus H2O giving, suppose my water is in large excess like a drop in an ocean. Okay, we think that rate law should be K 1 H2O power 1. Okay, but it is not H2O because of its large excess. So if from a ocean, if a drop is taken out to react, then only the reaction is done. Only the reaction with few drops of H2O is done. Then the rate law expression, then the H2O concentration also constant is also constant. Okay, then the rate law is equal to K dash C2H5 COO C2H5. This is K dash is pseudo first order reaction because it's a false reaction. It's a false constant because we do not know what is the order. So we have taken H2O as a constant value for getting the exact rate law for the pseudo first order reaction. Okay, I hope I am able to give you the glimpse. So So this is pseudo first order reaction. And after that, what is integrated rate equation? Now I'm going to explain what is the integrated rate equation. Suppose we have or we can say A, see, or A, B, okay? So for the zero order reaction, I am writing it. I have taken coefficient as 1, 1. Rate law expression, how we can write minus dA by dt. Okay, it's minus dA by dt. This is the rate law expression. Okay, now we can write k into a power 0, a power 0 because this is a zero order reaction, minus dA by dt. Okay, now the next step is dt you need to take over here, minus dA by, in a power 0 is 1, dA by 1. Okay, now I'm going to integrate it because this is a constant, so I'm taking it out from 0 to t and here from a naught to a. Okay, sorry, sorry, this is all. Minus dA by dt, a naught to a. Now k t minus 0 is equal to minus dA by dt. It will be a by a naught. Okay, so for after integration, upper limit minus lower limit, you need to put a minus a naught, concentration of a minus concentration of a naught. Here it is kt. Okay, here it is kt. Now I can write minus a plus a naught, right, is equal to k into t. Now by rearranging, a naught minus a is equal to kt and t can be calculated as a naught minus a by k. Okay, from here we can calculate t half also. I will explain it to you in this lecture. Okay, now the rate law expression or integrated law expression for the first order reaction. First order reaction. How I can write this? Suppose again I have A giving B. Rate law will be equal to minus dA by dt is equal to k a power 1 because it's a first order reaction. Now minus dA by A is equal to k dt. Okay, you can write, you can integrate on both sides. Okay, if we have any expression like this and integration of this, then you need to write ln t, or means ln means the integration and the differentiation. Now I have minus, suppose I am taking a naught to a t 0 to t, how I can complete it, minus ln a naught a here, k t t 0 minus ln, minus I am putting it here, ln a minus ln a naught k t minus 0. Okay, minus plus, then I can write ln A naught minus ln A is equal to KT. Okay, now if I am saying that what is the formula behind it, ln M, ln N, ln M by N. Okay, ln M by N, this is the formula. So ln A naught by A is the formula for this first order reaction. Now I am going to explain the T for this is T is equal to 1 by K ln A naught by, this is the integrated rate law expression for the first order reaction. Okay, so I have covered this R naught by R. Now the graph plotting, I'm going to tell you the graph plotting. I have explained the unit of rate constant for the zero order first order reaction. Okay, so I have this rate law. Suppose I want to tell you the expression of, or the graph of, sorry, or the graph of concentration versus time. Concentration versus time, then it is going to decrease. It is going to decrease. It's a straight line. It's a straight line. R versus T straight plot. Okay. Now the next plot is, now the next plot is, so this is ln y is equal to mx plus c. So this is our slope, k is the slope, and the integration value is 0. Okay. So this will be our plot. Integration value is 0, y is equal to mx. Okay. So this is our chemical kinetics topic. So now I am going to show you the half-life also. Okay. For the half-life, concentration of reactant will be equal to 0. So if I say at time t half, A is equal to A naught by 2. Okay. Then T is equal to A naught minus A naught by 2. So T is equal to 2A naught minus A by 2K, because it is going to get multiplied with the denominator. T half will be equal to A naught by 2K. So you need to calculate the expression for the zero order reaction. Okay. Now for the first order reaction, T half will be 1 by K ln A naught by A naught by 2. T half is equal to 1 by K, A naught cancel, ln 2 is equal to 0.693 divided by K. This is the value of T half. Okay, I hope I'm clear to you. Now the next one is, I have covered this plot, I have covered this, are not truly of first order, but under certain condition behave as a first order reaction. Acid hydrolysis of ethyl acetate, inversion of sugar is the example of this reaction. Then I have covered this one, order of reaction. Order of reaction, if it is a zero order reaction, then mole per liter per second. If it's one per first order reaction, then it's a second inverse. If it is a second order reaction, then it's mole inverse liter per second. I have covered this integration of differential rate equation to give a relation between concentration and at different times and the rate constant. Now, after that, I am going to cover with you the Arrhenius equation. Now, what is Arrhenius equation? Arrhenius equation is this one. K is equal to A e to the power minus E by A by RT. A is frequency factor. A can be written as frequency factor, pre-exponential factor, K is rate constant, EA is the activation energy. Okay, EA is the activation energy. So I want to tell you that how I can take ln here. Ln K is equal to ln A e to the power minus EA by RT. To get a value, suppose I have log ln m into n, then ln m plus ln n is the out. Next formula, ln K A to the power minus EA by RT is equal to ln K plus ln A to the power minus EA by RT. ln m power n has another formula m l n m. So this is my m, this is my n is going to be in front. Then ln k plus my minus ea by rt, because it's negative ln a. Then you will, sorry, it's it's this is wrong, this one is wrong, sorry. Suppose ln A e to the power minus EA by RT. This is equal to ln K. Then again the same formula, ln A plus ln E to the power minus EA by RT. ln E is 1. Remember that ln E, the number for this ln E is 1. Okay. Then ln A, this is minus EA by RT is in front of so ln K is equal to ln A minus EA by RT. ln A minus EA by RT. So this is Arrhenius equation. This is also an Arrhenius equation. Now what happens when the temperature, at two different temperature, we want to calculate the activation energy. I'll explain activation energy again. First, the formula is ln K2 by K1 EA by R 1 by T1 minus 1 by T2. 1 by T1 minus 1 by T2. Now, we can change. This is natural log. This will be log 10 K2 by K1 2.303 EA by R 1 by T1 minus 1 by T2. So this will be EA by R T2 minus T1 by T1 into T2. 2.303 log 10 K2 by K1. Log 10 K2 by K1 will be equal to EA by 2.303 R T2 by T1, T1 by T2. Okay, so this will be our formula for the activation energy. Now again the activation energy, if I want to explain you the activation energy, let me explain. So this is my energy profile diagram. This is my reaction coordinate. Reaction coordinate. Okay. This is the energy of the reactant. This is the energy of the product. Okay. Now the activation energy. See, this is my threshold energy. This is my threshold energy. Threshold energy. What is the meaning of threshold energy? Threshold energy is the minimum amount of energy. What it is? It's the minimum amount of energy that is required for the collision to occur. Collision to occur. Or the activation energy is this one. This is the minimum energy that is required by the reactant to cross this energy barrier to get into the product. This is the activation energy. This is the threshold energy. Okay. Now, the activation energy is the average kinetic energy of the molecule. Threshold activation energy activation energy is the threshold energy minus average kinetic energy of the molecule, because average kinetic energy that is associated with the reactant molecule, this is the activation energy. Okay. Now this is one. See, this is our activated complex. Here the formation of the activated complex take place. Activated complex. Now, what is another? This is activation energy that we have covered. Now, what is collision theory? See, what is collision theory? The rate of reaction depend upon the collision frequency and the effective collision. See, if we want that the reaction should occur, if we want reaction should occur, then what we need to do? At least some molecule need to collide with each other, so there must be collision frequency, number of collisions per unit volume of reaction mixture. The collision that is there in the per unit volume, then it's a collision frequency that it need to be in the some volume. Okay, so the formula for that is rate is equal to ZAB, means the collision between the two molecule e to the power minus EA by RT. And next one is effective collision. Next one is effective collision. Now, what is an effective collision? Effective collision means when the two molecules collide with the sufficient kinetic energy and the proper orientation. Means the kinetic energy also dependent and the orientation is also dependent. Suppose I have this one. I'm going to explain you. Suppose NO2 react to give N2O4. Okay, and we need a proper orientation like this. We need a proper orientation like this, but we do not have this proper orientation. We have this type of orientation. Now this is a wrong orientation. Our molecule are not going to collide. If orientation is not good, then the chemical reaction is not going to occur. So collision in which the molecule collide with sufficient energy and proper orientation for breaking of bonds and the formation of bonds. Now the whole rate can be explained by this. Rate is equal to P is at AB e to the power minus E by RT. P is steric probability factor. EA and the proper orientation determine the criteria for an effective collision. Okay. Now, this is a time in which the concentration, this is the half-life of a reaction, time in which the concentration of the reactant is reduced to one half of its initial concentration. So, T half I have already explained. All the mind map has been explained. Now, I am going to just give you a recap for what we have done today. See, firstly, I have explained to you the chemical kinetic topic. Firstly, I have explained to you the chemical kinetics, that it's a study of the dynamics, study of the rate of chemical reaction. Rate means speed, means with which speed a chemical reaction is going to occur. Now, after that, the rate of chemical reaction can have this definition, that change in concentration of reactant per unit time taken, then it's a rate of chemical reaction, that is mole per liter per second. Now, the rate of chemical reaction mole per liter per second, again another formula that we can do in terms of product. Product means the change in concentration of product divided by time taken. Now, what is the unit of rate of chemical reaction? The unit of rate of chemical reaction depends upon this one. The change in concentration of reactant means mole per liter, and with the time, then mole per liter per second. Then the rate of chemical reaction, if it is in terms of pressure, then you need to write it as atmosphere. The concentration, if it is in atmosphere, then if it is in pressure, then you need to put the unit as a atmosphere divided by second. Now, the next one is the average rate of reaction. Average rate of reaction is has been explained to you by the by taking this formula, change in concentration minus R2, R2 minus R1 divided by T2 minus T1, minus sign in front of this, because concentration cannot be negative, but R1 is greater than R2, then we will have a negative value over here. So we need to put a negative sign in front of it, so that we will have the overall positive value. Okay. So but the concentration of product is always positive. Now, I have told you how to write the rate of reaction if we have the rate of disappearance of A and the rate of disappearance of B, and something kind of this. Suppose I have this one, 4NO2 plus 5O2, giving 5NO2. I am just writing a vague example, but I am giving you the rate of disappearance of NO2, rate of disappearance appearance of NO2 is minus 6.5, 10 raised to power minus 4. I am not giving minus or plus, because disappearance itself means minus. Okay. So this is rate of disappearance. So 1 by 4, you need to calculate the rate of disappearance of O2. Disappearance of O2. Okay. Then 1 by 4 minus D and O2 divided by dt is equal to 1 by 5 minus dO2 by dt. So this we have this one for like 1 by 4 into 6.5, 10 raised to power minus 4, 1 by 5 minus dO2 by dt. This is rate of disappearance of O2. So 5 by 4 into 6.5, 10 raised to power minus 4 is equal to minus dO2 by dt, means it's a disappearance of O2. It's a rate of disappearance of O2. Okay. So this is the example of question that can be asked in the examination. Next one is rate of disappearance. I have told you rate of disappearance of R as decrease in concentration of R divided by time taken minus dr by dt divided by or you can write minus delta R by delta T. Next one is rate of appearance of P, increase in concentration of product plus dp by dt. It's a time taken. Next one is the factors that influence The factors that influence the rate of chemical reaction, it's a concentration that with increasing concentration of reactant, the rate of reaction will increase. Then the temperature, with the increase in temperature, the rate of reaction become almost double. Means with the 10 degrees Celsius rise in temperature, the rate of reaction will almost become double. Now the next one is presence of catalyst. Catalyst will enhance the rate of reaction by lowering the activation energy. By lowering this activation energy, you will get a good value. You will means reactant can easily cover this energy barrier. This is the energy barrier that a reactant need to cover to go to the product, energy barrier. Okay. And if the surface area increases, the rate of chemical reaction also increases, because with the increase in surface area, you will have more more elements that is going to react with each other. That's why the surface area increases, the rate of reaction also increases. After that, the rate law expression I have explained to you. I have written this reaction AABB plus DD. Then the rate law expression is the experimental expression that we can only write it by the help of experiment, but we can't write it theoretical, because theoretical expression is law of mass action. Law of mass action is the k into a to the power a, b to the power b. Sorry, not k. Law of mass action is equal to a to the power a, b to the power b. Means this is exactly same as the stoichiometric coefficients. Okay. Now the next one is rate constant. How we can define rate constant? Rate constant is equal to rate law when the concentration of reactant is equal to unity. Concentration of reactant is equal to unity, then the rate constant is equal to rate law. When I have explained to you the rate constant for the zero order reaction, means these are the units for the rate constant of zero order, first order and the second order reaction. The unit for the rate zero order, mole per liter per second. First order, second inverse, mole per liter per second. How we can write it? Mole per liter means 1 minus n. Here I have explained to you that this is the short trick. This is the short trick that we can use for the rate constant. Okay. So rate law is equal to k a to the a power 0 mole per liter per second is equal to k into 1. K is equal to mole per liter. So these are the some constants that we need to prepare. Next one is order of the reaction. We need to choose, just simply add. Addition of the powers of the rate law is will give you the order of the reaction. Order of the reaction can also 1.5, because if k a power by 1 b power half, then 1 plus 1 by 2 is equal to 3 by 2, that is equal to 1.5. Okay. So this is the order of reaction. Now the next one is molecularity of a reaction. Molecularity of reaction, that the reacting species, the number of reacting species that has been reacted to give the product. So A is a unimolecular reaction. More than 3 molecule itself cannot be the is difficult to react with each other at the same time. Now the order of reaction, the molecularity of reaction. Order is experimental, molecularity is theoretical. Order can be negative, zero, fractional, integer, but the molecularity cannot be zero, negative and fractional. Another example you can take, that molecularity is the sum of the reacting species, is the reacting number of reacting species that is going to react with each other. But the order is an experimental condition, and it doesn't depend upon the number of reacting molecules that is reacting each other. Okay. Now the next one is pseudo first order reaction. Pseudo first order reaction, I've explained that it's a false first order reaction. Means you don't know that whether the reaction is the rate of reaction is like this or not. But here I've explained to you that one of the reactant species is in excess. So if it is in excess, then you need to take it constant, because it is not going to to get more reacted. Means only a drop from the ocean is going to get reacted. So it's almost constant. So rate law is equal to K dash C2H5 COO C2H5. Now the next one is our integrated rate expression. I have explained to you the most better, and that the T half you need to remember. Here the T and the T half again you need to remember. You need also to remember that K value. K value. If the K value for the K, if the K value for the first order reaction means, you need to think about the K value. If by putting the values of the concentration, you have the constant value of K, then the that those concentration depends on the first order, means the concentration of the reaction depends on the first order reaction. If it matches with the zero order rate constant, then the reaction is zero order. Okay, so next one is, I will explain to you the Arrhenius equation. K is equal to A e to the power minus EA by RT. K ln A e to the power minus EA by RT. Activation energy is the minimum energy that is required by the reactant to cover the energy barrier. After that, I explain to you, this is the wrong thing. This is not the, okay, and also this one. This is the correct rate expression. Okay, ln k ln a to the power a into e to the power minus ea by rt, ln a plus ln e to minus ea by rt. Now the next one is collision theory. I have explained to you by the mind map. I hope I am clear to you. Thank you.